Here we've been given a linear inequality in two variables, and we're trying to find the solution for it by graphing it. Well, first, let's pretend that this is just an equation rather than an inequality. If we had x plus y equals 2, that would be a line in standard form. It's a line because the highest exponent is a 1, a degree of 1, and it's in standard form since the variables are together on one side, alphabetical order, positive leading coefficient, and no fractions. Now, when we've got a line in standard form, usually the best way for us to try to graph it is to try to find the intercepts. So let's do that. Let's take 0 and put it in for all the x's in order to find the y-intercept. Then let's put 0 in for all the y's in order to find the x-intercepts. Here, when I put 0 in for x, I'm left with 0 plus y equals 2, and so y equals 2. So our y-intercept, when x is 0, the y value is 2, and 0, 2 is our y-intercept. If we do the same thing to determine the x-intercept, only this time putting 0 in for y, we'll find that our x-intercept is 2, 0. So now if I wanted to try to graph this line, x plus y equals 2, I have a y-intercept at 0, 2. I have an x-intercept at 2, 0, and the line would look like that. Now, let's account for the fact that this is an inequality. This says x plus y is less than or equal to 2. So we've got to decide what things can be parts of our solution. The choices, we could have the line itself as part of our answer. We could have the area below the line as part of our answer, or we might get the part that is above the line as part of our answer. Now, since this particular problem says less than or equal to, since it's got the equals here with the underlined part, that means the line itself is going to be part of our answer, and we'll represent this with a solid line. So on our picture, you'll see a solid line going through those intercepts that we found. Now, I need to know, do we want the area that is above the line, or do I want the area that is below the line? The easiest way for us to do this is to use a test point. Now, if your line misses the point 0, 0, and ours did, then that's the best point for us to use because it'll make the arithmetic as easy as possible. 0, 0 represents everybody that is on this side of our line. So when we put 0, 0 in, we want to see, will it give us something that is true or false? If it's true, I'll shade over here on this side. If it's false, I'll shade the opposite side. So let's substitute it in and see what happens. Since the line missed 0, 0, that's the easy arithmetic for us to use. Let's put 0 in for x, 0 in for y, and do the arithmetic. 0 plus 0 is 0. That's less than or equal to 2, so this is true. That means we will shade the area on the graph where 0, 0 is located. Now let's go back and let's change this. Instead of it saying equals, let's make it say less than or equals, just like our problem says. And you'll see a solid line through these points, and we'll be shading over here where it's true. Less than or equal, and there is our solution. Anything on this side of the line is true since 0, 0 was true. The line itself is true, and we've represented it with a solid line. Now, think about, though, the other side. If we put something in from the other side, let's take the point 3, 3 and substitute it in. 3 for x, 3 for y, 3 plus 3 made 6. Is 6 less than or equal to 2? No, that's false. So we want that side to be unshaded Over here where 3, 3 was is unshaded, and we shaded the opposite side. So our solution is where it is true. We shade the portion that is true. We leave unshaded the part that is false. Now, for this problem, how would it be different if instead of having less than or equal to, we had strictly less than? That would mean that the line itself is no longer part of our solution. We have the same intercepts, we get the same line, we're going to have the same area to shade, but the line is not part of the solution. We represent that with a dotted line. Let's go back to our graph, and the change that I'll make, instead of having less than or equal to, let's change it to strictly less than right here. When I do strictly less than, notice that the line is going to change from a solid line to being a dotted line. When we do not include the line, it should be dotted to say this is the boundary between things that are true and false, but it is not included. Let's look at another linear inequality in two variables, only this time it is in slope-intercept form with the y by itself on one side. Now, just like before, let's pretend that it is an equation to get started. Y is equal to 2x plus 1. This is slope-intercept form solved for y. When we've got slope-intercept form, the number at the very back is the y-intercept. So 0, 1 will be our y-intercept and a point that's part of our picture. To get another point, we can look for the slope of the line. It's the coefficient of the x when we're in slope-intercept form. So for this one, the slope of the line is 2. That means from the point 0, 1, we'll go up 2 and over 1 to get a second point. On our picture, the y-intercept is going to be here at 1. From there, we'll go up by 2 and over by 1 to get another point. Let's look at how that would look. There is our y-intercept at 0, 1. Up 2 over 1 gives me another point. Now, let's account for the fact that this is an inequality. Since it's an inequality, greater than or equal to, is the line going to be included? Yes, it is. When we have that equals, the line is included. So when we draw our picture in a second, the line will be part of it. We'll still see a solid line since we had the equals. Now, I need to know if I can test with 0, 0 or not. Did the line miss 0, 0? Here's 0, 0. The line missed it, so we can use it as a test point. When I put 0, 0 in, if it's true, we'll shade on this side of the line where 0, 0 is. If we put 0, 0 in and it's false, we'll shade the opposite side away from where 0, 0 is. So let's test and see. When I put 0 in for y, 0 in for x, and I do the arithmetic, 2 times 0 is 0, I'm left here with 0 greater than or equal to 1. That is false, so I need to shade the opposite side of the line. The line will be solid because of the equals, but we're going to shade over here away from where 0, 0 is. Let's change it to greater than or equal like our picture says, and there you see the solution. The part that is shaded is true. The line being solid means that it is true, and the part that's unshaded, that is false. Here is one more linear inequality solved for y. Now, just like before, let's pretend first that it is an equation. So let's imagine that it says y is equal to 2x. And this, of course, is in slope-intercept form. Since there is no constant value back at the back, that means the y-intercept will be 0, 0. It's just like we have a plus 0 at the back. So the y-intercept is 0, 0. Again, the coefficient is 2, so the slope will be 2 for our line. So this time we're going through 0, 0, and then we'll go up 2 over 1 for another point. I'll see a y-intercept here at 0. I'll go up 2 and over 1 to get my second point. And here goes our line just like that. Now, when we think, though, of changing it to an inequality, it's maybe going to be a little bit tougher. When it's an inequality, the first thing to notice, I've got a strictly greater than here. Since it's strictly greater than, should the line be included? No, we're going to need to make a dotted line. Now, the second trick here that is something we'll have to deal with, I can't use 0, 0 this time, because if you remember, our line goes through the point 0, 0. So I can't use it as my test point. I'll have to pick somebody else. Now, you could pick any point that the line misses. I'm going to choose to use the point 0, 1. I think you'll see why once we look at the picture. If we take 0, 1 and we put it in, 1 goes in for the y value, 0 goes in for the x value. 2 times 0, of course, would be 0. So now I've got 1 greater than 0. And this is part of why I wanted to use the point 0, 1. Since 1 is greater than 0 is true, that means we're going to shade where 0, 1 would be. Let's look at our picture. Here is where 0, 1 is. So the part that's true is up here. That's the part that's going to get shaded. So now let's change it from being y equals 2x to what our actual problem was, which was y is greater than 2x. Remember, this is the area to shade, and it's going to change to being a dotted line since the line itself won't be included. Let's see if that's true. It is. A dotted line goes with a strictly greater than or a strictly less than. When we cannot use 0, 0, just pick somebody else that the line missed to substitute in. If it's true, you shade that side. If it's false, shade the opposite side.